right, recording is back rolling. We're in about the last 10 minutes of class. You guys have been working on this class at this point. So I'm going to come back to these numbers and just model some more example for you guys. Okay, so let's say you had these angles. No, I don't think these are 100% accurate, but we're going to run with it. So take the sine of each angle. So I have 24 degrees versus 13 degrees. So you go sine of 24 degrees, and I can write that number down, 0.407. And then sine of 13 degrees, and that's 0.225. Okay, so now I have sine of each angle. Sine of angle, sine of angle. Okay. And inexorable fraction of error, we're going to call 1. So I'm going to do 1 times sine of the angle on the side of error, which is just this number, 0.407. So, okay. And then I divide by sine of, so we're taking the ratio of these sines. So all I have to do is divide by sine of 0.225. Okay. That tells me the index refraction of the glass. And here I got 1.8. You see that? 1.8. So I would say, whoops, I meant to do this all on this side. So this was 0.407, 0.225. Okay. So this came out to 1.8. Okay, based on 1.8. I think that's a little bit too big. What were you guys getting for this value?
2.17.
Huh. Okay. Well, it should be somewhere in there. All right. All right. I think, having done this last so many years, usually this averages somewhere close to 1.5-ish. Now, there are different materials out there too. Some of you guys have a glass piece, some of you guys have a plastic piece, so those might not even be the same. Okay? But somewhere in there, okay, is what you should be looking for. And I was walking around, some of you guys have that. Okay. But let's run with this number, because I still want to find the critical angle. Now, again, there's 2 ways to find the critical angle. Okay, one way is you can find this experimentally. You can take this laser all the way to 90 degrees, and this will refract naturally on the inside at what ends up being the critical angle. Or you can find this mathematically, and that's what I was showing you guys right before I closed the last video. Because now at this point, we know this index of refraction of the glass piece. Now I'm going to use mine, which is 1.8. You see 1.8? Let's try this. So, guys, what is sine of 90 degrees again? 1. So we go 1 over 1.8, because I'm going to divide that down. And how do I extract theta out of the sine again? What do I do?
Inverse sine.
Inverse sine. So it's really inverse sine of this, isn't it? So let me do that. I'm going to go inverse sine of 1 over the index of refraction. You see it? Again, I'm just using my numbers, which I've been telling you guys I don't think are 100% accurate. So if you got different numbers, that's probably good. Okay. But I'm getting the critical angle is 34 degrees, I'll call it, to the nearest degree. It's 33.7 degrees. I'll call it 34 degrees. Okay? You guys see that? Okay. So that's how you could calculate the critical angle. Okay, you just do this math right here after you know the index of refraction. Okay. All right, so I will throw this video on Google Classroom also.